So someone asked about the homework description for today, and it says like top of page 8. The top of page 8 is this page. We will not have covered proportional lengths, so it's just the problems above. So pretty much there's more problems than that we have for notes than we're actually going to go over, and then your homework will be to complete the problems that we didn't go over. And then a few fill in the blank proofs. So we're going to start at the top of page 5. And let me activate the chat so I can see you guys type as we go. I'd like you guys to type into the chat privately as we go through the notes. I can just check to make sure that you're understanding what we're covering. And let me just make this a little bit bigger. Sorry, I'm using just to let you guys know. I know it was a challenge in the last class. It's like working too much of my brain to, and with Calc, I had a program on my old laptop, which is Windows, and then trying to learn a MacBook. I don't know if any of you guys are used to Macs yourselves, but it's very different. It's like going from an Android phone to an iPhone, I feel like, which I've done before. But there's just, I've done Windows all my entire life. So switching to a Mac and then like not having the right click button has been, I thought it would be a lot harder, but it is tricky when you're like working with Windows and then switching back and forth between the two. Kind of like have to actually tell my brain switch gears and do this instead of that. So at the very top of page 5, you guys will see that just kind of in summary for what we're going to look at today, the objective for today is similarity and looking at just triangles. So I want you guys to remember when we were doing triangle congruence, remember you had to prove like all 3 sets of angles were congruent and all 3 sets of sides were congruent before you knew that the triangles were congruent. And then we learned all these like acronyms like side, angle, side, angle, side. All of those were shortcuts because then it was saying if we knew all 3 sides were congruent of 2 sets of triangles, of 1 set of triangles, then we would know that the pair of triangles are congruent to each other without having to know anything about the angles. That's what side meant in when we were proving triangles were congruent. Type yes or no if you guys remember that. Like those were shortcuts, right? Side, angle, side, angle, side. Do you guys remember that from before break? We were proving triangles were congruent. And then just even to take it one step further, after the triangles were congruent through side, we would then know that the angles were congruent by Cpctc, right? Because corresponding parts of congruent triangles are congruent. And so now relating that with what we're moving into next is now we're talking about similarity between triangles. So triangles that have the same shape, but not necessarily the same size. So think of your meme project, you guys, when you are doing 2 things and you're looking at 2 things that are in proportion, all the angle measurements are the same, but the size of the sides are different, right? They're proportional to each other. They're in what we call in proportion to each other. So 2 things happen. You can always show 2 triangles are matching up corresponding sides to show that they are that the sides are in proportion. So at the very top, you guys can fill that out. So 2 triangles are similar if the sides are in proportion, and then that the angles are what? If two figures are similar, the angles are blank, and then the sides are blank. And I just remembered that I haven't gone over the homework questions with you guys, so I will do that at the end. I will get back to that. Okay, good. So sides are in proportion. Angles are, so 2 figures are similar if the angles are congruent and the sides are in proportion. So angles are congruent. Angles have the same measurements. Sides are in proportion. So kind of remember that for what it means to be similar. Okay, but then that would mean for 2 triangles, I would have to show all 3 sets of angles are congruent and all 3 sets of sides are in proportion. So what we learned today is kind of similar to the congruence. We have some shortcuts. Okay, and one of the shortcuts is if you know this AA similarity postulate, if you simply know that 2 angles of a triangle are congruent to two angles of another triangle, then you can conclude that the triangles are similar to each other. Okay, so if two angles of one triangle are congruent to two angles of another, then you can conclude that they're similar. So what we'll do is work through some examples below using AA. The question is, tell whether or not the triangles are similar or not similar. And then if you can't reach a conclusion, write no conclusion is possible. So here you guys have three possible answers. Yes, they are by AA. No, they aren't. We know for sure they aren't from the information given. Or the third possibility is we actually technically don't have enough information. So I'm going to say no conclusion is possible. So there's a difference between no, they are not similar versus no, no conclusion can be reached because I don't have enough information. And so I'll point out the difference to you guys. So we'll start with number two. With number two, what we're going to have to do is at the surface level, looking at those two triangles, we have 150, so that's great, but then 160, 170. So if there's an angle missing, go ahead and find the missing angle. Can you guys type into the chat, what is the missing angle for the left triangle? What's the missing angle for the left triangle? Okay, so triangle sum theorem is 180 degrees, minus 110, very good, 70 degrees is that missing angle. And then at this point, if you're looking at the two diagrams, you could already make your conclusion. However, I'm going to go ahead and figure out the third angle as well and just point out why this similarity postulate is true. So if you guys can figure out the angle on the right triangle as well that's missing, can you guys go ahead and figure out the missing angle there as well? Okay, for the most part, okay, good. I see someone corrected themselves. Thank you. And it does help for you guys to put that asterisk, so I know you guys figured it out. But yes, 60 degrees is the correct answer for the angle on the right. And here's the thing, if you guys know let's say we had stopped at finding the 70 degrees. If I knew that this angle is 50 and this was 50 and that's 70 and that's 70, the third angles must be congruent to each other. And so that's why a similarity postulate only requires two angles, because if two angles are already congruent to each other, the third must be congruent to each other. And so at the minimum, all you guys need is two angles. So technically we could have stopped here after we found the 70 and we saw that it matched with this one. We could say, yes, we have enough information. They are similar by AA. Okay, and so that's going to be your justification for it is angle. How about number three? Okay, you guys want to think of all of the conclusions you can draw from properties that you've learned before, of theorems that you guys have learned before you guys make the conclusion. Yes, no, or no conclusion possible. Think of everything that you guys know about triangles that you can conclude from the picture that is drawn. Okay, so I'll wait a little bit longer. Again, type in yes, no, or no conclusion possible. Okay, so the very last one I just saw here says yes, because of vertical angles theorem. Okay, so and this is kind of leading into the proofs that you guys do. This is what you're going to do is same like with triangle congruence. You know that these two angles are congruent to each other and that the 90-degree so these two angles are congruent to each other by vertical angles theorem. Then you got this angle and this angle are 90 degrees, so they're congruent to each other. So therefore, the correct answer is yes, and that is by AA, that it's congruent. Okay, and so let's take a look at number 4, because this one's an interesting one. Okay, so the answer was yes, and by AA for that one, through vertical angles theorem and the fact that right angles are congruent to each other. For number 4, can I have you guys write your answer as yes, no, or no conclusion possible? What do you guys think of number 4? Okay, good. Those of you guys typing it in, that is correct. Okay, so let's see. What is the only thing that we can conclude about this diagram? That we have a right angle on the left. So this other angle next to it must be, since it's adjacent and makes up a straight angle, that must be 90 degrees as well. There is nothing else in the diagram that I can use to conclude that these angles are congruent to these angles. Even if they might look like it, we technically don't know. We don't have enough information in this case. So this is an example of you don't have enough information. So this is no conclusion possible versus yes or no. Okay, so no conclusion possible. All right, you guys, so 5. Can I have you guys go ahead and figure out 5 for me? Actually, can you guys start with figuring out what is the missing angle down here? What's that equal to? On the left triangle that I highlighted. If you guys got 60, maybe double check it again. If you got 20, double check it again. Okay, so the majority of you guys got it correct. Base angles theorem is what some of you guys are saying, which is true, but I think maybe just a simple mistake as you guys did it. 180 minus 40 is 140. If you divide that by 2, then each one of those angles are 70. And you want to do that first before you guys say no conclusion possible, because you want to make sure you guys are filling out the diagram as much as possible. So you guys have 70 degrees here. And then can I have you guys figure out this missing angle, these missing angles here? Or sorry, the top angle or the bottom angle. And then let me know what your answer is. Okay, and then as you guys type in the answers, very good. Can you tell me what is your conclusion? What is your conclusion? Is it yes, no, not possible? Okay, so for this one, you have all of the information for the angles, so you can make a conclusion. Your conclusion should be that no, you don't have two sets of angles that are congruent to each other. So the correct answer was no. Can you guys now, what is the difference with, yeah, I was gonna say, can you guys type into the chat if that makes sense to you, the difference between no conclusion possible versus no? No conclusion possible means that like I didn't have information on these angles to say one way or the other whether they're similar to each other. So if I had more information, they could be similar, but they also could not be. So since I don't have enough information, this is no conclusion possible. This one, I have enough information on all the angles for me to draw the conclusion that definitively this is no. Okay, so can you type into the chat right now? Yes, that makes sense to you. The difference between no conclusion possible and no. And no, if it's no, I can clarify further. Okay, so you guys are writing that it makes sense. And that's basically, do I have enough information to draw a conclusion? All right, so 6 is definitely the trickiest one of all. Can I have you guys type into the, and some people had a hard time seeing what are the two triangles. These are two overlapping triangles. So you have the yellow triangle there, and then the one that I'm going to trace in pink is the other triangle. Okay, the small and the, so the yellow and the pink. What do you guys think? Yes, no, no conclusion possible for this one. This one's a tricky one. Okay, now what I want you guys to do is if you answered yes, okay, what I know for sure you guys see the 45 angle degree that you have here is congruent to each other. But what other information are you guys using to make the conclusion that you're saying yes on? So we definitely for sure have that angle is 45 degrees. Okay, we want to be careful. Someone says they share a side. When we say they share a side, we want to make sure that the whole, well, and first we didn't have anything yet about sides in terms of similarity. It's just we need two angles, but this is not really considered a shared side unless the entire side is shared. And since they're overlapping each other, okay, so okay, here's where I wanted to point out what some conclusions are. Some of you guys are dropping the words SSI, corresponding angles. So if they are corresponding angles SSI, what information would you need to know in order to draw conclusions about corresponding angles or same side interior angles? Sorry, I felt a sneeze coming on. Okay, parallel lines. You would have to know information, corresponding angles, same side interior angles, alternate interior angles. Those are features of parallel lines. Are those lines parallel? Are they given as parallel to us? We don't know if they are, is what someone said. We don't know if they are. And so as tempting as it might be, we want to make sure that the conclusions we draw are based off of things that are given to us. And we are not given that those lines are parallel. So we technically don't know. And so this is an example of no conclusion possible. Someone said that the base angles of both triangles are 45 degrees. But that is true only of this, of the pink triangle, that these are 45 degrees and that's 90. Technically, we don't know that this base angle is 45 as well, unless these lines were parallel to each other. So very tricky on that one. Okay, so we would have to know that these lines are parallel in order for these corresponding angles to be congruent. So this is not enough information, so no conclusion possible. Yeah, that one's a tricky one. Okay, so the next aspect of this of these examples is just figuring out missing sides. So given the diagrams, we'll just continue practicing recognizing AA. But like, let's say, take a look at number 7. If you guys look at 7, you see that that you have overlapping triangles again. And although someone had mentioned shared sides, it doesn't share a side, but it does share something. What do these two triangles share, you guys? The pink triangle and then the yellow triangle. What do they share? Okay, and when we say share, it means that it has to have exactly the same measurement, right? So they don't share a side because the sides are not the same length, but we see that they share the top angle, right? The yellow triangle completely overlaps the pink triangle on the top. So this angle up above here is through reflexive property. We know they are congruent to each other. So yes or no, you guys, are the yellow and pink triangles, are they similar to each other? And I want you guys to contrast this example with the one that we just did, number 6. Do you guys see how the corresponding angles in this one were given to us as congruent, whereas this one we don't know? So even in this case, through the converse of corresponding angles, we would know these lines are parallel to each other. And so yes, these triangles are similar to each other. And so given that information, now we go back to the things we were doing before break. If the yellow triangle and the pink triangle are proportional to each other, then what is our scale factor? So we look for the sides that have the most information, the left side, the right side, or the bottom. And so we see that we have the most information on the left side. Can you guys tell me what the scale factor is for this problem? What is the scale factor for this problem? And as you guys type it out, ask yourself, does that make sense? What you're typing out. When I go small to big for the scale factor, yellow to pink, does it make sense that my ratio is what it is? Okay, some of us are typing in 2 to 1 or 1 to 2. Does that make sense with the image that you guys see? Are they 1 to 2? Okay, now what I want you guys to do is watch my cursor when I do this. Okay, the left-hand side of the yellow triangle is a length of 4. Okay, I'm comparing that to the left-hand side of the pink triangle. Okay, which is not, it's not just 2, because that's just this segment right here. I wouldn't say that this is proportional to this, right? I would say that the left-hand side, and then as soon as you guys figure it out, like you corrected yourself, go ahead and type into the chat with the asterisk. This left-hand side, this yellow, is just this segment here. The entire side of the pink is 6, right? It's the sum of 2 plus 4. So very good. Many of you guys corrected yourself. So 4 to 6 is the correct ratio, which reduces to 2 to 3. So those of you guys, good job on getting 2 to 3, 2 over 3. So then what we do just before break was we set up proportions from there, right, to figure out the missing sides. So can I have you guys figure out x first and then type it into the chat? Figure out what x is equal to and then type it into the chat. Good. Some of you guys are quick. Okay, so 2 to 3 equals, so always go yellow to pink, 2 to 3 equals yellow to pink, x to 6. Okay, so then we have x is equal to 4. Now y is a little bit more complicated, right? We want to picture what I did with my cursor, right? The right of the yellow to the right of the pink. Okay, so if I set this up, it's 2 to 3 equals, can you type it into the chat to see if we have the correct proportion? 2 over 3 equals blank. What is the blank? If you guys also wrote y to 3, can you guys think about how we did the 2 to 3? Okay, and then see if you can correct yourself, self-correct before I give you guys the answer to that. It is not y to 3 or 3 to y or y to y. Look at the right-hand side of the yellow to the right-hand side of the pink. The right-hand side of the yellow to the right-hand side of the pink. And then think of the operation. Good. So think of the operation that you guys were doing to 2 to 4. Did you 2 and 4 to get 6? Did you guys times it or did you guys add them? Yes, Jared, that's correct. No. Okay, very good. So much better. If I'm looking at the right-hand side of the triangle for the yellow, that's a length of y. And then if I look at the length of the entire pink side, that would be y plus 3. I would add the units of measures, not times, to find the total length. So y over y plus 3. And that's one common mistake that I see is just in solving that. Can you guys go ahead and solve the rest of it and then tell me what you guys get for the answer? Okay, very good, you guys. Y equals 6. I'm trying to figure out which other one. I'm not doing all the examples in case some of you guys are like, that's so many examples. That's part of your homework. So what I'm going to do is jump to number, like we'll do 10 and then we'll move on from there. So on number 10, if you guys take a look at that, you have two triangles. Can you type in yes or no? Those two triangles are similar or not? Yes or no? Are they similar? Okay, at this point, if it was a proof, we would say they are similar by AA because of the vertical angles. So we would say first, vertical angles are congruent. Then we would say that it's similar to each other by AA. And then from there, since we're trying to figure out missing sides, we find the side that we have the most information on. So here's the challenge. What do you guys think the scale factor is for this now? Let's go small to big. So small on top, big on bottom. What to what? And if I can have those of you guys who typed in 2 to 3, if you guys can look again at the triangles, look at the ring markers on the angles to orientate yourself to see if you guys can figure out the corresponding sides. And you guys can keep scale factors as fractions as opposed to decimals. And if I went small to big, so if you guys notice that the most information you have is either on this 8, 5, or 12 side. So to figure out what matches up with which, notice that 8 is between the single and double ring mark. So 8 therefore must match up with Y, which has the single and the double ring mark. That means the 5 and the 12 match up to each other. So if I'm going small to big, it should be good, 5 to 12. Okay, and then from there, you're going to go 5 to 12 is equal to blank to blank. Can I have you guys next solve for x first? Okay, perfect, you guys. X is 24 is the correct answer. Someone said, how come we don't add the 5 and the 12 in this problem? The only reason why we added in the previous problem is if you look at the pink triangle, the pink triangle is made up of, it's kind of like giving you segments of the pink triangle. So if you look at the number 7, they're saying this part of it is 4 and this part of it is 2. So to find the entire sign, like they didn't give you the total. So you have to find the total yourself. They were overlapping. That's why you have to add it. Whereas number 10, the triangles aren't overlapping. They just give you the side length of it. So there's no need to sum up the side lengths. All right, so 24. And then if I can have you guys go ahead and solve for y as well. So remember, you guys always use the same scale factor. Once you've established what the scale factor is, you guys can use that same scale factor. And you guys can always leave it as just a fractional value as well. So just kind of getting used to not having to do decimal values. I know at least when we get to higher level of math, we just leave it as a fractional value. You don't have to write it as a mixed number even. You can just leave it as a improper fraction. Yeah, that's something that, it's like, I always wonder when do we tell the students that, but all the advanced level students, they know that you just leave it as an improper fraction. Unless you have to interpret it in some way, you can just leave your answer as that, as a reduced improper fraction. You don't have to convert it to decimal. Okay, you guys, so the other type of problem that you guys will have from this is on the next page. So if you guys can scroll to the next page, we're going to do one of these problems. And then I'm going to move on to the last two things I'd like you guys to know. Okay, so in this example, you guys are given a proof, which is the type of proof that you'll see tonight, fill in the blank proofs. So you have, and you're given that angle 1 is congruent to angle 2. That is given to us. And so we see images that were familiar to us because we just did problems like this. We applied problems like this. By reflexive property, we see that the yellow triangle is overlapping. So the person who just asked about the previous problem, so this one's another case where you guys have overlapping, right? So in this problem, we're trying to decide if the triangles are similar. And notice that what we're trying to prove is something about the sides. So we will get to how we can get from angle measure similarity to something about the product of the sides. Okay, so if I can have you guys tell me on step 2, what angle do I know is congruent to itself by reflexive property in this picture? What angle is congruent to itself? Sorry, I kind of wrote over the angle. Okay, do you guys all see how angle B is overlapping itself? So therefore, the yellow triangle has an angle B that is congruent to the pink triangle that also has the angle B. So we would say angle B is congruent to itself. And then down for number 3, you guys can see that they stated a similarity statement, and the similarity statement is kind of like the congruent symbol, except it doesn't have the equal sign underneath, right? So you want to say that triangle BDE is similar to triangle BCA, and make sure that the letters correspond to each other, just like it did with congruence. And what would you guys say? Why are those two triangles similar to each other? At this point, we only have one reason, right? Okay, yeah, all you guys have to do is write AA. That's the reason why. So if someone can remind me of this, when you guys were doing congruence with triangles and you got to a point where you just proved that the triangles were congruent, just like we got to a point where we just proved the triangles are similar. Oftentimes after that, there was something that we stated almost like 100% of the times, if the proof kept going, what was it that followed the triangles being congruent? Okay, so all of you guys are typing in Cpctc. We've seen it so many times. And just to remind you guys of what Cpctc stands for, it's corresponding parts of congruent triangles are congruent, meaning that the corresponding parts are the angles are congruent to each other, that the sides are congruent to each other, that all of those that match up are congruent to each other. With similarity, it's different because you have the angles are congruent and the sides are in proportion or proportional. So we don't have just one acronym like Cpctc that we can use, but if we know Cpctc, we know that the next step is something similar to that. So this one unfortunately doesn't have an acronym. We just kind of have to spell it out or write it out. So if you take a look at the next step, step 4, you see that they did what we were doing in the application problems above. Once we knew that the triangles were similar, if we were asked for sides, any information on sides, we are starting to set up proportions. So we would say that corresponding instead of corresponding parts, we would talk about corresponding what. So the corresponding what part is, it could either be angles or it could be sides. Since this is talking about sides being in proportion, we would say corresponding sides of similar triangles are either in proportional or in proportion or proportional to each other. So, or proportional. So corresponding sides of similar triangles are proportional. Okay, so that's the equivalent of Cpctc, except for, again, we have to spell it out. Angles are congruent with similarity, sides are in proportion. After that, if I look back at my applications, if I set up a proportion, what's the next step that you guys did to solve for it? After you guys set up the proportion, how did you guys get this step? What were you guys doing to get this step? Okay, good, Emily. So Emily mentioned that right after you guys set up a proportion, to solve a proportion, we would do something called, most of you guys would say, we would cross multiply it, right? So if you look at the number step 4 and then step 5 being what we're trying to prove, if you cross multiplied, you guys would get this expression that they have here, that product. So BD times CA, I'm just copying down what we're trying to prove in case it looks a little jumbled there. BD times CA equals BC times DE. And instead of saying cross multiply or simplify, there was and kind of like a more official name for the property, and that's called means extreme property. And so that's like 90% of the similarity proofs kind of have those steps. You have, you're trying to prove that it's similar through AA or the other two that we're going to cover right now. And then corresponding sides are in proportion, corresponding angles are congruent, and then means extreme property if you mention sides and you have to cross multiply. Okay, so that's another way of saying cross multiply. Okay, so now what I'm going to do is skip this and then talk to you guys about the last two things. And then we're done. That one we're not going to cover as many examples because we're just setting it up in AA and they're similar. Okay, so at the top of the next is, and then let me know if you guys still are working on the proof so that I don't move down. Give it another few seconds there. And so you guys, right now at this point, we just have AA. Notice that everything, all the problems above there, the only way to show with our shortcuts that two triangles were similar was through AA. Now what we're going to talk about is two additional ones. And similarity is nice because there's only a total of 3 that we learned of. There's going to be AA, which we've now all memorized, and then 2 other ones, which sound very similar to the ones that we've covered before. Okay, so this one is called side angle side similarity theorem. So this is side angle side. And so you might think, okay, well, didn't that mean that the two triangles were congruent if the sides were congruent and the angle included were congruent? And the answer is, the straightforward answer is yes, that did mean if I knew that the two sets of sides were congruent, the included angle was congruent, then we can conclude that the sides are congruent. This one is different in the sense that when we talk about similarity, we're talking about the sides being in proportion to each other and not that they're equal to each other. So look at the diagram that you guys have below. I would say that these two triangles are similar because 5 to 10 happens to be in proportion to each other in the same proportion as 11 to 22. Okay, now the sides, when we say side angle side, now the sides are in proportion to each other and not congruent. Okay, so 5 to 10, and I can write that down below here. 5 to 10 is equal to 11 to 22. Okay, so that is true. And then you also can conclude that it's similar because the angles that are included in between are congruent to each other. Angle A is congruent to angle D. The sides that surround it are in proportion to each other. So this is another way of showing that two triangles are similar. And your conclusion, just again, as you guys write your similarity statement, make sure that the angles matched up. So like triangle ABC should be similar to triangle DEF. And then we would say by SAS. Okay, so that's the secondary reason. The third reason is also easy to remember. The third reason is similar to what we had in congruence, except for this time, it's just all about sides. So you guys have one where it's just angles, angle, angle. Then you have one that has 2 sides and then the angle included. And then all 3 sides are in proportion to each other. So on the next page, you guys see that an extended proportion is written below there, but you guys can see that if I were to fill it in with numbers, 5 matches up with 10. So 5 to 10 is the scale factor. And can we make a conclusion? All we would have to show is that all the proportions or that this extended proportion is true in that the scale factors are the same for each one of the corresponding sides. And then Sydney, let me know if that's far enough up. So we can see it's a 1 to 2 scale factor for all 3 sides. And so if we can show that that's true, then we can say that those 2 triangles are similar to each other. Okay, so we're going to do one last example. Sydney, let me know if you're done. Okay. So I would like you guys to, for this example, if you guys can just not mark on your diagram, if you have it printed off, don't mark on it. I'll mark on mine so that we can save the marking for part B. Okay, so for part A, it's asking you guys, are those two triangles similar? Before we only had AA, now we have side angle side and side 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 as well. Okay, so I'm gonna mark off what's given to me for a minute. So SP is 8, TS is 6, and PT is 12. So this is 12. I'm gonna switch colors and then mark off the other diagram as QR is 12, PQ is 9, and RP is 18. Okay, if a similarity statement is given to you guys, you want to make sure that the sides match up to each other. So what I do is I use my angles as a marker for what matches up with what. So angle, when they say triangle PQR, and that if I'm looking at angle P, what should angle P match up to in the other triangle? In the bottom triangle, what should angle P match up to? Based off of your similarity statement. Go back to reading this, you guys. If you read the similarity statement, what should P match up with? Okay, since P is the first variable in this statement, T is the first variable in the statement, T should be what it matches up to. So what I like to do is mark that off in my diagram first. And again, I'll do all the marking. So P matches up with T. Can you guys tell me what should Q match up to? What should Q match up to? If they were similar, what should Q match up to? Good. So Q is the second letter. Second letter in that statement is S. And I usually just need 2 angle markers to then now know that how the sides match up, right? So if I'm trying to compare the sides to see if they're similar to each other, there's no information on angles given, but all the sides are given. So I'm going to see if the sides are proportional to each other. Can you guys type into the chat, what does PQ match up to on the bottom triangle? What does PQ match up to? I'm trying to find the scale factor. Okay, so you guys see single ring and double ring here, single ring and double ring. So very good. You guys said 9 should match up with 6. Good. So let's go ahead for part A. You guys can write this part out. Your scale factor is 9 to 6. Okay, we're going to see if it's true, if the extended proportion is true, 9 to 6, which I know reduces to 3/2. Let's see if it matches up with the other sides. Okay, so if I pick now, since I went big to small on this one, I said 9 to 6. Let's go ahead and go with 12. What does 12 match up with? What does this 12 QR match up with on the other end? And you guys can just give me the numeric value. Okay, good. So 12 to 8. So I'm going to write should match up with 12 to 8, and then we'll verify if that's all true. And then lastly, your base of each triangle. So what does the 18 match up with? Okay, you guys, can you go ahead and reduce all 3 fractions and tell me if that proportion is true or not? Okay, yes or no? Are those sides proportional to each other? Okay, so the way that I would answer this question is to write out the proportion and then to say, yes, the question is, are they, can the information prove that those triangles are similar? We would say yes. And the reason for that is side, side, side. Okay, all 3 sets of sides are proportional to each other. All right, you guys, so the next step I'd like you guys to do for part B is, since I marked on mine, I can erase mine, but go ahead and mark up your diagram with the information for B. Take a moment and do that for me. Notice that the pink is something I'm just marking off in the diagram like I did in the previous example, just to show what angles match up with what angles should match up with what angles, so that I can, again, position myself to figure out which sides match up with which sides. That's all it's there for, the pink. Okay, the green is what is actually given to me. So I'm going to point out one thing first. They gave you guys that the sum of angle P down below here on the big triangle and angle R is 100 degrees. Does that give you guys enough information to solve for Q? And if so, what is the value of Q? What's the value of Q? Good. If the bottom two angles add up to 100, then the top must be equal to 80 degrees. Very good. So then that should be a clue for me. So right now, when I'm trying to prove triangles are similar, it's like if they're giving me information on sides, this is what I'm going to show. If all I'm given is angles, then I'm going to try to see, can I get two angles to be congruent? And then for examples like this, you have something that has angles in it and sides in it. So can I use side, angle, side? So let's say for sure we know angle Q is congruent to angle S, right? So angle Q is congruent to angle S, that checks off. Now we're trying to match up the sides and see if it's proportional to each other. Can you guys tell me what should match up with 9? What should match up with 9? On the other, you can just give me the number. What matches up with the side length of 9? And make sure you guys are looking at the ring, the markers for the angles. Okay, I think I had one person say 7. It can't be 7 because of the fact that 7 is between 2 and the blank marker. 6 is the one that's between 1 and 2, and then 9 is the one between 1 and 2. Okay, so 9 to 6, so that's important. Make sure that we have the correct one. And we're to show, since I went big to small, that 9 to 6 is really the equivalent of 10.5 over 7. Okay, I wanted to show you guys how to simplify 10.5 over 7, just in case we forgot how to, because it's not considered simplified if you guys have a decimal within a fraction. So 10.5. So let's say you guys had 10.5. As an improper fraction, if you guys remember, you were to multiply, if I were to convert this into an improper fraction, it would be 10 times 2 is 20, plus 1 is 21, right? So 21 over 2. So if you guys had 21 over 2 divided by 7, and then had to simplify that further because you can't have a fraction within a fraction, you might remember keep, change, flip. Keep, change, flip said you keep the top as it is, you change the division to multiplication, and you flip the bottom. Flip the bottom means that if this is 7 over 1, its reciprocal is 1 over 7. So you guys, when you reduce that, do you guys get the same scale factor as 9 to 6? Okay, can you guys type into the chat for what reason, yes or no, are these two triangles similar based off of what you guys see, and why, if it is, what's the reason for these two triangles being similar? Okay, you guys had the angles were congruent. The included angle are congruent to each other. Very good. That the two sides that are surrounding those congruent angles are proportional to each other, shown by the work down here. And so your conclusion is that, yes, they are similar to each other by side, angle, side. Okay, so showing two